I'll put it together and I'll have an actual real informational video. That's at least the goal. I've been filming myself, like doing all the solder work back there. So, if you don't know about Society V1, this is the project. That not this. This is my GitHub repository, and you can come and you can check this out. It says a social calculator, all that stuff. If you want to read into it, the white paper is really what has the basics of everything. Whoa, whoa, whoa. Okay, here we go. So this is the white paper. We will not read through this, but if you want, you can. So there's 42 variables, and each variable has a slider attached to it. Let's see if I can. So here is the mock-up of the 5 sliders, which is the prototype, and each one of these is a slider with it's a potentiometer. So if I turn it, I can turn it down, I can turn it up to 100, and the voltage gets higher or lower, and then the processor pretty much picks up on it, so I can know where it's at. And you can see the cool things about these are these motors that drive them. So I actually have multiple motor drivers here, 3 of them. Actually, for demonstration purposes, I'll show it again. I'll keep showing it, but you know, this is incomplete, so you're not going to be able to understand it, but I'm going to show you an example, okay? So you got these sliders here, and inside are the motor drivers in here, and there's a microcontroller that controls it all. I also have these OLED screens. I'm not a big fan of them. I'm not a big fan of these OLED screens. If you can see in here, here's the screens. They will not sit on the board right here. I've actually decided that I'll just have pins sort of on this board, and how I have it in here, if we can, which direction is going to get me closer here? Let me get a good monitor preview so I can see if we are okay. Okay, you can see back here. Yep, I actually 3D. It's like 3D print the pen. The 3D. I glued it. I welded it in with a 3D pen. Okay, so that's these little screens right here. Okay, so each of these screens, it's a lot to go over every time. Okay, so every single time it either works or it doesn't, and for some reason this doesn't have. It really confuses me. I didn't even think to try this last time I tried to preview this, because this one gives me problems all the time. Let's just. There we go. Well, we got a light. Oh. Okay. So. Okay. Let's move this battery here. Okay. All right. So here is the single example. Now you can see here I can turn agriculture up and down, right? So if I want more agrarian resources, more capacity, more, not so much infrastructure, I'll show you what these actually mean, because each of these have specific definitions, right? But this is agriculture, and then what I could do is using a single. Oh, I push this button now. Hold it, and then I can go and I can go to say transportation, sickness, racism. We can go to racism, right? And we could turn racism down and up. What does that mean? Okay, and I actually don't have racism anymore. I took that off and I aggregated it. So now I have a discrimination variable. So, oh, let's get me back in focus. Okay, so I'm using a prime lens, which is great with film, but terrible with things like this. So, whoa, sick. All right, that's the preview. Okay, so so what do these mean? What does agriculture mean? Let's just go through the definitions real quick. I'll try to just go through. Okay, so we got these. We'll go to the anatomy. This document here, the anatomy of the 42. This will go through more of what the heck does it mean. So, so like this addiction. We'll go to addiction. It encompasses the severity and pervasiveness of two primary dependency domains: substance use disorders and behavioral disorders. So, and it goes through what does it include? Well, the pervasiveness of addiction, severity and chronicity, recovery and relapse dynamics, economic, judicial, and social. A lot of this is abstract. You're like, Evan, what the hell? Okay, now I go through and I explain what exactly these mean and how do we actually quantify them, right? How do we, because we need to represent addiction with a number between -1 and 1. It's called normalization. Now this is it is probably right on the boundary of what we would consider word embeddings, right? That's what you would use for like large language models, AI. It's how you kind of calculate context and just meaning in a word, and you embed a value to it, and you'll layer tensors of it. So you'll have a matrix or some kind of vector, and you'll layer the context of, like, it'll be this number in the context. So if I have the word happiness in the context of emotion, it'll have a value, and then in the context of adjective or verb or something like that, it'll have another value. So there'll be all these values. It's called word embeddings. I'm not going to go into a lesson to it, and I don't even think I could give a good lesson on it, but just think it's similar to AI. We're going to do it to these societal concepts. Now, a really good example, just so you can see what the hell is going on here. Let's go back to the white paper real quick. Let me grab this link. Unless I have the link saved. I don't think I have the link saved on this one. Okay. So we'll just... So here's sort of the matrix right here. I have a spreadsheet. If you want to understand... Now, I do have another document that I'm working on, which is all the math. This is just the basic math. So if you're fairly good at mathematics, this should at least get you there. Get you to see the vision, but it's not showing you the gears under the hood. So I have another document for that. But this will make you go, oh, okay, that makes sense. So right here, this is what I want. I want... What just happened? Okay. We want ARS dot electronica dot art slash hope slash en slash sliders of society. Okay, so this is sliders of society. Okay, now you notice here they have, what is it, 4, 8, 12 of these. And let me... There's a way that... Is it gone? I think it's gone. But anyways, here's one. Now you can see here there's a bunch of concepts. There's CO2 emissions, there's unemployment rate, there's total energy use per GDP, there's gender equality. And hey, can you please be quiet? All right, keep it down. Sorry. Education, social trust. Now when you move these, they all kind of move together. Now, I don't want to insult anyone. They made an amazing project. In fact, it's partially what inspired me to do this. Now, I had the idea, I looked it up, and then I found this. So I did kind of have the idea on my own. I do want to claim credit for that, but they did it way before me. Now, again, this is not an insult. I love their idea. I'm just taking it to a whole level of complexity. They use very linear relationships, okay, where if you move one thing, it's linear. Okay, let me think how I can articulate this. If I moved one down and another one went up, I could reverse that by moving that other one back down. You know, like I could just easily go back to the same state by reversing one. Mine has higher order relationship. So if you screw up the economy, it's not as simple as just turning economy up. Okay, like it uses non-linear conditional algebra. Okay, and it's a mouthful. So real quick, okay, I'm trying to go through this quick. There's not really a way to do so, but I'll go to some of the simulations that I have. If I can find them, where did I put the simulator? Testing? Okay. Hopefully this one still works. I haven't used these in a while. Okay, so this is sort of set up like my my prototype, where I only have 5 broken out. Now see how they have 12? I will have 42 of these, and they won't be as big. Theirs is actually going to be more mechanically cool because they built the sliders, the motors inside. I'm using the same sliders, motorized sliders that are in mixing boards. I'm a musician, and I was like, those things are awesome. Now they're really expensive. So anyway, so here we go. So, where's my nudge button? Oh, there it is. Okay, so, and what I could do is I could turn down, so I could say, let's see, corruption to public trust. Let's do racism. We'll go to, remember, racism is not one of these anymore. We'll go racism to public trust. If I turn racism up, public trust will go down by a quarter, by 0.25%. We'll also call that a soft clip. Soft clip might work. Okay, so let's apply the nudge. Oh, we got to move it now. We got to move racism up. We're going to move racism up, and watch. We will see public trust. This one requires a lot more programming. Okay, so here we go. Public trust just went down. We have a little bit more stress here. All right, now let's also say that if we have police force to public trust, that'll be a little positive. We'll even call that a little linear. So now we'll get in our police force right here. Okay, let's see, we'll apply a nudge. Nothing moves, so we're still the same. Now let's increase our police force a little bit. Oh, well, look at that. That starts going up. Now this is just only on to public trust. Now let's also affect freedom of speech, right? Freedom of speech might increase liberty, right? Liberty. But racism also takes away from liberty, right? That's less liberty. Which one's liberty? 24. 24. So here, we'll call that -2. Actually, I should look up my matrix so I could actually use some of the values. So we'll do that. We'll also bring in liberty here. Liberty is 24. So here we go. Now we turn freedom of speech is 13. Okay, so we turn up freedom of speech. It's more police force. Liberty. This requires, I should have set this up prior. Okay, let's do more liberty. Okay, so racism affects liberty. Let's actually do it like this. Liberty affects freedom of speech. It works better when you have more of these. So more liberty is 0.2. Freedom of speech. Police force. I don't know. We'll do sigmoid there. We'll say 5. Cost of living. Okay, so something has to affect. We'll also say diversity and racism. Diversity, I don't know. Diversity reduces racism. So we got racism, public trust, police force. See, I kind of have to program these for them to all affect each other, but we kind of see the idea here. I have a simpler one where I don't have to program things like that. Which I think... Nope, that one requires programming. Okay, here we go. So this one is a linear. These are linear. I think they're linear. Uh-oh. What's going on here? Alright, we'll skip it. These are too old. I probably moved them. They're not working. Okay, yeah, they're not working. So now what we can do is you could say, oh, where do all these come from? You know, how are you getting this information? Let's just use addiction just because that one is sort of done, right? And now you can see the output edges. So when addiction's outputs are these ones, and these are the non-zero ones. So it goes to a bunch of different ones. I drew a little graph here. You can see addiction gets pointed to agriculture, but it doesn't affect authoritarianism directly. These are direct relationships and influences only. Okay, so we could say that addiction, how does that affect crime? Addiction directly influences more crime by 0.3, so almost a third. If I turned addiction up 100%, then the crime rate would also increase by 30%. Okay, so and then it's a strong increase inducing desperation, impaired judgment, and social destabilization. So these are not just arbitrary, okay? We have a research repo. We'll go to the research repo. We'll go to addiction. And like we want to go to crime, right? Which we said it was 0.3, right? Plus 0.3. So a positive influence of 0.3. Positive is it increases it. We can go to the notes file here. I'll write notes for most of the stuff. I have a shaping note. Here's some of them I have ranges, so keep it between +2.2, plus 0.37. Substance use disorders show a strong consistent association with criminal activity. That's cool to note, but here's the crux. These are research documents. There's different papers. So I have resources in here. Fact sheet, drug-related crime, you know, criminal reactions to drug-using offenders, the systematic. There's a bunch of research inside of all of these. Anyone that has an actual influence. If it's a zero influence, some of them don't have any, and there'll just be a note that says, hey, this has no empirical evidence. So, all right, so it's a physical device. There's a simulation around it. I highly recommend you check out this GitHub. Okay, you can see here it's at github.com/thesoundofcolor/society-v1, and that's all you need. You just need that society-v1. I'll put it in the description as well, or if you comment, just ask for it, and I'll reply with the link to this. So that's pretty much it. So I need to get to building, and let's see where we're at here. Okay, so I want to take these OLEDs off. Oh, which I think I did. I think I took them off. I just didn't update the board. Yep, it's true. So here we go. Now this time I'm just gonna put pins, these through holes on there, and I'm gonna wire them manually, and that way I can also keep this fairly small. Because this, I've never built a board this big before. I literally have no idea how the manufacturer is going to handle this. And then we'll also distribute vertically. Okay. Okay, and I also need the button ladder, which the button ladder I will also hook up separately. So how do we want to do this? We want to bring these over here. Now the big problem that I've been having is power distribution. So that's really what I want to focus on, but okay, let's just get these distribute. Okay, let me think. We want to get some jumpers. So we want I want to say these are the motor pins. Let me look at the... I think I have a data sheet open somewhere. Where would that data sheet be? Right here. So A and B. So we got 1, 2, 3, T, then A and B. Let's look at this. T, A and B. What is L? Now we do have 4 pins, right? Of course, we have the wiper pin, which is 2. Then we have the 2 top and bottom of the potentiometer. We have T, which is the touch pin, essentially. What is L? Would that be the chassis? I didn't even use that. Lug terminal. There is an L. Okay. So we don't need to worry about L. Yeah, I can see them right there. Okay, so yeah, LL. Okay, so maybe I'll ground them. I have no idea what the lug terminal would be used for. Okay, so but A and B is what we want to connect to. Alright, let's actually get these out of the way. These are the OLEDs. Ooh, whoa. We need to group these. PCA 9548A. I love that I can remember these, and I can't even remember anything else, but those I can remember. Okay, so we got so we got TB6612 FNG, and we'll call that driver 1. Okay, and then that one and that one. We'll call these driver 2. This one and this one we'll call driver 3. Okay. Oh no. Can we turn all of it? There we go. Okay. Maybe we shouldn't. Maybe we shouldn't. Let's do it like this. So both of these. Okay. So we'll get these 2. 1, 2. Oh, come. That way I can have them to the right. It's okay. We'll just put these designators in there. You know, I probably don't need these designators, but I try to make it a habit of including them. So motors are to the right. Okay, correct. And this one just gets one motor. Let's do this. Let's do this the quick way. So that should be 1, U1, U2, U3, and U4. All I gotta do is change this now. U1, 2, 3, oh, U3, and then we'll switch this one to U4. Okay. So we got motor 1. Okay, let's think of how we're going to do this. Wire this. Boom. A2. Okay, and then for this net, we will call that all 6s. Same thing with this one. This one we'll do the dark red. Not the prettiest, but you know, that's what we gotta do. And then we got that, and then, oh, I'm not vibing with this. I'm not vibing with this. It just doesn't look pretty enough to me. Okay, let me think. We got 1. Whoa. We got 2. Okay. We'll call A. See, this one will work Yeah, that's A. We could also put some X's. I hate crossing over like that, but you know, you gotta do what you gotta do. Okay, let's grab these. Here we got a ground. There's really no other way. I hate that. I hate it. I hate it. I like making things look pretty, but you know, you can't always do it. You can't always look pretty. Okay, now let's get some nets in here. VM actually is 5 volts. Yes, I confirm. You know what? We'll keep that VM. We'll keep that VM. And we'll keep that VCC. Okay. And then for this, okay, we want this to be, you know what? Get out of here. I'm done messing with you guys. Okay. So how do we want to do this? Okay. Let's go to our pinout map for our STM32, and we want to look at these. That's the motor drivers that we're currently connecting. So PA. Okay, we're gonna add D1, D1. Let me just copy that. That way I can just hit one of these. Standby will actually be shared, so I could just leave it like that. I don't think I'll ever need to actually control like specifically one motor driver. I'm just gonna turn them all off or have them all on. Hmm. Okay, let's course. Hey, can I just do that for all of them? Guess not. Oh, we don't need that. Yep, we just have a ground connection for that one. I'm not going to do anything funny with grounds. We're just going to keep them all common. Alright, well, that's one. Let's get these out the way. Okay. So, pretty much... Whoa. What's going on here? B. Okay. So, we definitely want to go 1, 2. Okay, we'll wait to put these. I don't know which is which. What we will do is put number 1 to the left. That means 3, 4. Okay, what do we got here? That is U3. So that will be the next one. U4 and U5. Okay. Next, I do not like that they're that long. Because on my prototype, the drivers are like right next to them. Let's see if we can actually get rid of these. Have something like this. Like have it be right up on it. I think we'll do something like this. Boom. And these go to boom. And that goes to boom. then we'll have these guys right at the edge of the board. I should be able to route to them. My 3D print is failing. Kinda is. Okay. I think that's enough room. You know, I might even have some room to spare. So let me just save that. All right, we got those motors. Let's just keep moving. So we got A. Yep. Okay. Boom. We'll ground it. Ground you out. Ooh. VM. Alright. Ground it out. Ground it, ground it. Alright. 2 more to go. Oh, we actually we gotta do one of these right here. D2. Then I'm gonna copy the suffix. Then when connected Pt.2. Oh. to do a lot of these. Doesn't look like I'm going to be able to really automate this. Is that ground? Width. Can we not snap like that? We cannot control a snap, can we? Alright. No, that's not what I wanted. Okay, let me just bring it back to these. Okay. That's sorta what we want. Okay, we're getting closer. Let me just edit these to be the other side. Okay, that should work. Okay, then we're gonna do just gonna take forever just to get some pins set up. Stand by. Copy pasta, copy pasta. I mean, really, I'm gonna do this for every single pin. Why? Because no mistakes. Oh, and I made mistakes. I already made mistakes. This is all upside down. So this is pin 6. Pin 7. And pin 8. PWMA D1, AN2, AN1, standby. Yep, yep, yep. Okay, now the only difference is there we go. We'll call this driver 1 right. And this is going to be driver 1 left. So now we're going to save those. We come here. Yep, driver 1 left. Driver 1 right. Okay. So now we just need to do rinse and repeat, right? Just do it again and again and again and again. Let's connect the motors. Color these in. Red. And there we go. So there's the motor pins. Alright, now let's go back to here. And what we will do is I'm going to actually call it what it is for these. to call it exactly what it says on the pins. I don't like that. I don't like that at all. There. Much better. Okay, well, why is... ground, okay. We want... Same thing here. Go to there. Ah. Spin that around. Give this the designator right here. Spin it around. There we go. Now, let's see. 3, 4. Wait, 3. This should be going... Oh, man. Okay, let me think here. So this is... A is going to 1. B is going to 2. A is going to the wrong one. Alright, let's try that again. That should be untangled. And it's not untangled. Oh, that's right. It is untangled. There we go. Ah. Let's align left, distribute, vertical. There we go. Now these go to there. These go up, down. There's still this crisscross. I hate that these pins do this. If you notice, it goes plus, minus, minus, plus. But hey, I guess they probably have a reason for that. Okay, and then this 9, 10, 11, 12, 13. There we go. I'm almost ready to start routing. Okay, so grounding is going to be a little tough, but I'm pretty sure I know. I think I want to I'm not sure. It might be better to do a ground pour on top. I might do a ground pour on top and route my signal on inner layers. Ooh, speaking of which, oh, I'm not tracing yet, so I'm not gonna get to my design rules yet. Where I'm gonna set up a 4-layer board. Okay, but we will do this, and we will set our net ties up. Why is it doing that? There's gotta be a way. I think it's because I messed up, but I went and named everything. But hey, I need these to be designated. Everything needs to be designated so I don't mess anything up. Okay. I am worried about length. So I'm gonna probably need to place some caps. But 473. What kind of caps am I using here? Let's see, cap 473. Capacitor is 47 nanofarads. Okay, so we want, that's what we want to get. We want 47 nanofarads, not microfarads. Really don't need SMT. I mean, I could do surface mount, but thin film. Let's see, plus 5%. Let's just get to the capacitors here. Capacitors. Ceramic. We want 47 nanofarads. And these are for the motors. It's a availability. Let's see, size, through hole. What's a ceramic? Alright, you know what? It's not that big of a deal. I don't mind the SMT. We'll do a surface. Surface mount. You know, I have no idea what, I mean, I would use this. I just use ceramic capacitors, but what would be the best kind of capacitor for my DC motor leads? but what would be the most ideal? Lower ESR, aluminum, polymer. Oh, here we go. Estimating current variation. Average with the current increase on. Alright, I'm going to need to do some testing then to figure out what kind of amps I'm drawing. Alright, I know 47 will be fine, but if I'm going to put a bypass cap on it too, you know, which I might as well. I don't need safety. Hold on. $240. Jesus Christ. What kind of capacitor is that? I like to do availability, but they're all SMT. There, I'll just select all the through holes. There we go. $50. I mean, that's high. 7R. Okay. I like that this one's smaller. It's rated at 50 volts. I know Vishay is a good company. Murata is a great company too. Let's see. Cent 2.5. I think I'm gonna go with that one. Damn, $1.41 for one of them. Come on, that's that name brand. I mean, I'm tempted to do it. Let's see, 41 cents. 600. That's a high. That's too high rated. 50 volts. Where's that Vishay one? Here we go. 66. That's really what I want, and it's small. That's what I want right there. So these, we'll grab that. All right. I don't know why these are that. All right, let's do C1. C2. Okay, so it's C1, C2, C3, C4, Okay, so these are really tiny. These are really bypassed. These aren't even bulk now that I realize it. So hold on. I'm going to want to place these. I'm also going to want to bypass. So according to, I'm going to read through this, but it looks like, okay, that's the motor driver. This is for the motor driver itself, which I already have capacitors on them. Let's see, I have 104 and 105. Let's see. Capacitor 104. So I have a microfarad. I have a zero point 0.1 microfarad and a 1 microfarad on the driver side, and supply voltage variations. Same as other types. I have that 0.1 and then 1. That's what I have. And then a local bulk capacitance. Okay. Yeah, I have all these. I've actually done some good capacitor setups, but it's the motor itself that I want these across, so these should be fine. Now on these pins, the VM and VCC pins, I'll have some other capacitors, but these should be fine. So let's just throw these in. Now what if I throw this down there? Will that clear it? Yeah, look at that. I can do that. Now wonder if my design rules will get mad at me though. Okay. Put that one there. That one's there. Oh, this is gonna be cool. I guess these should be able to all... Yeah. 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 Alignment left. Let's check that out. Oh, come on. That's gotta be good. That'll work. That'll do. Now the only problem though, I would kind of like to put these on the other side, because when I'm routing in this way, let me actually... Okay, so when I'm routing this way into these, I would like to come through this. Let's see what this would look like. Ooh, is it touching? It's barely touching. Oh, come on. Let me see. I'm going to check the design rules. Let's see. I mean, I guess I will, because everything's not touching. Okay. Oh, but honestly, it's just connection errors. But there's no error on this one. Can I check the just the DRC for just that component? Yes, I can. Okay. We don't want connection errors, right? We want to get rid of them all. Check. That should be fine. I think we're going to do that. Alright. So let's check that out now. Alright, now we just gotta worry about the silk screen. Okay, hold on. Wait, let's align these up. Let me think about how we align these. Align. Yep, okay, that works. Align. Align vertical center. Align vertical center. Okay. Now we just select these. Align to the right. Okay, and now I need to edit the footprints. Edit footprint. Here we go. Only selected components to the whole project. There, we'll just do that. There we go. Make sure no silk screen is anywhere. I like it. We're looking good. Okay, we're also going to need to work on connectivity. But hold on, let me just... that and that. Alignment, vertical, horizontal centers. Okay, the only way to really do this is to draw an actual line. We'll just draw a straight line. Have that be a guideline. Now for here to here. Okay. Move it even closer. Now we can make this smaller. Ooh, okay, we're getting there. We're getting there. We can probably get even closer to the edge. How close are we? $100 mils, 2.54. Actually, we're good. I'll leave it at that. We have more tolerance, but we'll leave it at that. Oh, let's get rid of this. Alright, let me just think. I could move these up a little bit more. I got the hidden capacitor right there. Okay, we're also going to want $470. Okay. So this is going to be the local main cap right here. Alright, let's clear these. Oh, wrong kind of cap. Electrolytic. Okay. So $470, 35. Hold on. $470. Ooh, those are nice. HOK. Okay. Let's see. 470. 50. 86 cents. I do want a big cap. I would not be opposed to that. $10, 25. I mean, these are very high values. So, I mean, which is good. I want it to be a lot higher, but I don't want it to go crazy past. Without doing the math, roughly, I mean, it's not super important. I think anything past 16 volts will be plenty fine. Let's see what company. I I think I do want to go with these name brands. So we'll do this. So coming into the board, that's our input. Then we're also going to want, I think I got a 680. So when it's even bigger than this. $680. 25, that should be fine. $35. That's kind of too big. So it's 47 cents. 680. Ooh, plus 20% though. I don't like that. I guess that's pretty standard then, huh? These are huge tolerances. 20% tolerance. Could we do like a 10% tolerance? I guess that's not very common. So 680. Size 8 by 16. 8 by 11. That's I think we'll go with this one. Nah, let's just go with just through hole components then. Let's just do that. Alright, 10, 17, 8. I'm using a 16 volt right now. I think it's the same one. It looked. Oh, okay. Let's do that. So here. Yep, all the VMs. So. Then ground. also call this, we'll call that plus 5V in from the buck. The buck converter. Okay, so every 104s, let's look up that. 104 is 0.1 microfarad. $310 volts. Alright, I need a through hole. Only show in stock. There we go. That's what I wanted. I am about to be. Alright, let me just set these last capacitors. And then I'll be done here. 16, 37 cents each. Vichy, hold on, here we go. These are what I want. Same company. If you do it by the same company, it's better to source it like that. So these are going 1, 2, 3. These go on the VCCs. So we got 1, 2, 3, 4, 5. Then we got C6. C7, C8. Oh. C9. C10. Okay. We'll ground them. Then we want these to all go to VCCs. So, okay, these are all decoupling. we'll also call this oh god dang it, caps lock. Am I spelling that right? Why doesn't that look like I'm spelling that right? Decoupling. Decoupling. Yeah. Decoupling. Okay. So we got those. Okay. Yeah. I used the right terminology. They could be called bypass caps too. It says it's used interchangeably. Ooh, my 3D print. Terrible. Terrible quality. Some little alligator clips for chip bags. I'm probably not gonna use this though. Not with this. This is a crappy old filament. Yeah. My 3D printer has been broken for some time and I recently fixed it. Still having some problems though. Alright. I guess I'm gonna take a break. I'm gonna let my son. He wants to use the computer, so I think I've done enough work for right now. I'm gonna go read my book and relax. Hopefully I cut some good footage in there. Like I said, I'm just streaming all my work and then I'll eventually just collect all the good highlighted footage and put it in my actual main video. So if you're watching this, I guess that's cool. You know, thank you. I definitely appreciate it. If you got any questions or comments, you know, I'll reply. And yeah, y'all have a blessed day and pray for the troops kicking ass. And hopefully everything will end soon and they'll get to come home. So doing God's work. Hopefully society will be the prototype. I want it to be finished by the end of the year. But if I keep putting hard work towards it, I could realistically see this thing working in a couple months. 3-4 months. So we'll see. But yeah, you'll have a great day and love you. Bye.